Hi. So someone gave me this part of a ceiling LED that was broken. He broke it while he tried to fix it. And what we can see is that the connector tore out the PCB. The PCB is torn from the panel. You can see the trace was taken off because he accidentally removed it. Now I will try to fix it, but before I will try maybe to see if these scope lights are lighting or whatever. So when you come to trying such a thing, of course I don't have any parameter of this LED, so I know nothing, but I know that if I will use low current, so for sure nothing will happen. So what I'm going to do now, it looks like a high voltage. When I'm talking about high, I'm talking about more than 12 volts. So I will set my power to 30 volt, and of course I need the current limit in order not to break the LED. So I'm putting now 20 milliamps, and another thing, I don't know what is the positive and what is the negative, so I just up. So you see it? This is very strange because I'm using very low current, so why should it act like this? It looks like the LED is broken, because if I'm limiting, so I will move now to 12 volts maybe. It is lower than 12 volts, or 7 volts. Seven volts give me nothing. 8 volts. Sorry, 8 volts. So this is probably also 8 volts. Now I will go to 30 milliamps. So eventually I have no idea what is the voltage that it can deliver. Let's go to 50 milliamps. Maybe 100 milliamps. So let's go to 10. What I'm just doing a try and error to get to acceptable light and acceptable voltage. By looking now, I see it is written on the panel that it is 7 watt, so I should get 7 watts. So each one probably is 3.5 watt. So if it is 3.5 watt, now I am at 1 watt, so probably 12 volts. 12 volts, now it is only 1 watt. I will apply 150 milliamps. This will be now 1.2 watt, and the other is also 1.2 watt. So eventually the LED are okay, so there is no issue with the LED. I don't know why he take it off. But it looks like I'm now working on 12 volts, but the voltage is now 8 volts, so probably if I will go to 12 I think it will be okay. So I'm just now playing with the current to get to voltage that looks acceptable to me. Now it is 1.6 watt, so I'm about half power of what this LED should deliver. Okay, so basically what I'm seeing now, that the LED is okay. There's nothing with the LED. So the next thing is to see where it did tear off. So I will try to find to do a better zoom, and I will show you where it goes and what is tear off, and then we'll try to understand. There is no electronics, just one diode in the circuit, and probably the plus is connected to the minus, so all the LED is one parallel out. So probably, if I'm seeing correctly, so let's find something. So okay, so this is probably the minus for all and this is the plus for all, and now it is not working because the voltage probably should be 24 volts and not the voltage that I'm using. Yes, and now you see both are working at the same time. Now it's 3.5 watts, about half of the rate. How did I know this? Very simple, because I see the short here on the PCB between both sides of the LED. So what is left is this, and that's all. And about the diode, I'm not sure why. About putting everything back, probably it was like this. I will try to fix the PCB for him, and then everything is torn off, but I can see what is going where. So basically I can put epoxy and then connect this part is going to this diode, and then we have these two sides here. I'm just curious which one is going where, so I will use the Fluke to. I'm just trying to understand. I see that this is part one and this is the other, so I don't know why I need all the other parts. So let's see what is going in where. Maybe one of the sides is going. Yes. So this is just in order to connect the LED in the correct polarity, and it is going to this part. So this one should go or to here or to here, but it is not beeping. So actually I don't understand why it is not beeping. Another here, another here. This is beeping. So this is the other side. So why do I need the third one? Not very clear. Okay, so basically it will work for him. I just need to glue it and then connect the wires. This one is going to the middle. I can see the trace here on the PCB. It's going here, and the other one, I don't know what is the purpose of it. Really don't know. But this is the other one. So what I can do, I just can, of course, connect everything as I see it now. So maybe I will draw for me how to connect it. So if I'm gluing it like this, so this part will go to the diode. The middle we said will go here. Yes. So this will go to this LED directly, and the third one, which is the middle, will go to this part on the PCB. I'm sure, maybe the other side. No, this is the third. Okay, so the third is going to this part of the port 4. So the third is going here. So basically I can glue it and then connect everything with wire, and it will be okay for him. Yes, these wires are very good, don't see any issue. So now it looks like this. I connected everything. I put another Kapton in order to isolate it from heat, and now I will glue it with epoxy, and then we'll test that it is lighting, and this is basically all. So let's try it now to glue it and then test it. So I've now glued everything and already connected the two wires. So let's try maybe to light it up now. This should be the plus. Already power up my power supply. This should be the minus. Anyway, we have protection diode if we mistake. And now, aha! So it looks like it's working perfectly okay. By the way, the color is the same. It doesn't look the same because there is a Kapton tape that's now catching this connector here that I've done. Maybe I can already remove it. I think it's not fully glued, but it's okay. Let's say for now, I think that it will catch it good enough. Okay, so you see the lights look the same. They are identical. So that's all. I hope this is helpful to anyone that have something similar. And that's all for now. Thank you and bye.